Good afternoon, Kartik.
Hey
Welcome
man,
to
how
the
you doing?
second episode. I'm doing amazing. I love the momentum we picked up on this. And the format really showed that we could make impactful content last time, where we talked about smart homes. And I'd like to keep the momentum rolling and go right into it with our mass timber field trip we did last week and start exploring the technology. The most interesting topic is the Sperling development, which I'm so excited to be on board. Can you talk a bit about the size and scale of what we're building up in Barrie?
Welcome to Enginerding Out, where sustainable building design gets stripped to the studs, with Daniel and Kartik. High performance buildings decoded. This is the podcast for people who know details matter. Buildings are sexy.
Yeah, so we are building 1,000 units, 1,000 residential units, still under development. It's not under construction yet. Going through the design development and feasibility stage on this property. The building is going to be made out of mass timber. So it's the largest residential mass timber project in North America. It's going to be over 1,000 units. Phase one is going to be 300 something units, and the remainder of the units will be added in future phases. Very exciting project. Right now, mass timber buildings can be up to a height of 18 stories here in Ontario. There are some states that allow for mass timber buildings to go a little bit higher. So I believe in Milwaukee, they have a mass timber building that is 25 stories high. Our building codes are not that advanced here in Canada yet. So we're kind of capped at 18 stories. So basically, these buildings are some of the most sustainable, energy efficient, architecturally cool buildings in, I would say, the world.
The reason that's not so hard to believe, like walking into the Element Factory last week, which was in St. Thomas. So we took the drive out there. We got to really see the product in action. So it's cool to see how the floors are being manufactured, the pillars, every single part of the building that you would typically assume to be concrete, pillars, floors, and even some of the more niche products. They were using it for acoustic treatment, so it's really taking the wood and making that product into many different use cases in the building envelope. So what that's going to do leading into our next topic of embodied carbon and also the health benefits. When we talk about the scale of the health benefits, that you walk into this 18-story building and the doctors have studied that it'll reduce your stress levels. So not only are we building mass timber in terms of 1,000 units, 18 stories, that alone, that would be impressive already. And then once you throw in like the health benefits of this, it's a really meaningful project.
Yeah. A lot of times people don't understand the value of mass timber. So let me kind of explain some of the benefits of mass timber compared to going with conventional systems. So one of the biggest benefits of going with mass timber is, we're in Canada and timber is a local industry to Canada. When we build out of timber, we're localizing our housing construction infrastructure. When we build with steel, when we build with concrete, we're importing that from other countries and overseas. Timber is available in plenty and allows us to domesticate our supply chain. Daniel, did
Right.
you have something you wanted to add to that? Or?
Those products were coming from Timmins, which is just northern Ontario. You're reducing the amount of fuel that you need to transport those products to. And like you were saying, the trees are actually a renewable resource. A lot of people think that you're using trees and it's going to be wasteful, but it's actually very sustainable logging practices, and you're reducing the fuel that's needed to transport these products, and it's great for the economy, right? In addition to the fact that concrete and steel are not necessarily our forte domestically.
Well, the amount of carbon that you need to produce to create a concrete block or steel beam, you need to spend a lot of energy to be able to create these structural elements of a building. Whereas trees, you don't need to spend that much energy because wood stores carbon. When you live in a mass timber building, the timber itself is actually carbon negative. It's absorbed all that carbon over, each tree's absorbed all that carbon over its lifetime. And And when you're using steel or concrete, you're actually releasing carbon into the atmosphere to create your concrete block or your steel beam. Mass timber is one of the most sustainable ways of building infrastructure, so much so that when you build with concrete and steel versus using mass timber, in terms of embodied carbon, it actually takes you 15 to 20 years just to pay back the amount of carbon you've spent in your carbon you've spent in producing the concrete and steel that goes into a building. Yes, you could have a very energy efficient building. You could have a passive house building that uses very little, energy, but the amount of energy it takes to produce that concrete and steel, 15 to 20 years to get a payback on the amount of carbon that it releases. Climate change is a real issue and it's affecting us now. And mass timber is one of the most sustainable ways of building these high-rise and mid-rise buildings.
Right. And you really hit the needle on the head with that because it's a natural cycle of biology of the way the ecosystem works. As the tree grows, it absorbs the carbon, something you learn about at a very young age. When you really explain it to people that way, all the carbon that that tree's absorbed over its lifetime, instead of being like released into the atmosphere, that's why it's carbon negative. We were just at the facility ourselves, and this jumps into the next topic, but there's really not a lot that goes into the process in terms of refining, believe it or not. You saw the lumber yard itself, and within a few hours, it's refined into the finished product. There's no heavy industrial products. It's very natural and simple. And the less steps that you're using in terms of chemical refining, the better the result is going to be, right? There's no waste. You don't need a lot of chemicals or burning fossil fuels, anything like that. It's just picking the wood, cutting it to the size it needs, measuring it in terms of the specifications. So, like, you can speak on that even more, but because this stuff is prefab, it's a very streamlined, lean manufacturing process.
Yeah, absolutely. That manufacturing process also has very little waste as well, right? Because essentially what they did is, they received the timber, the 2x6s, they received those from a lumber yard, made sure that the moisture content in the lumber is, to the specifications. And then they have a whole process of joining and forming strips of these 2x6s to maximize the strength and reduce faults in the lumber. There's a lot of testing and x-rays that happen to every single one of the planks, and then how it gets cut and how everything gets joined and structurally joined to a point where you're using it on an 18-story building for columns and beams.
The manufacturing process speaks to the cutting edge of automation. You're building as much as you can before it even arrives on site. It's done in the factory, and this reduces the amount of steps, less transportation, it touches less hands, goes from the lumber yard to the manufacturer and then straight to site. People wouldn't know that the amount of engineering that goes into this sort of thing.
No, they wouldn't, right? And we saw that every single piece of lumber or every single panel, for example, the first phase of our building is going to be about, 400,000 square feet. To have 400,000 square feet of panelization, every single one of those panels is individually labeled and gives you instructions like Lego blocks of how everything is assembled together. The precision manufacturing, and this is not being done by humans, by the way, this is all being done by robots and automation, right? Like it was pretty crazy to see how, they just have this lumber for a specific job. They input the parameters. I'm sure there's a lot of engineering and CNC and programming and it goes behind the scenes. But from our perspective, when we were doing the tours, we've got this bulk lumber that's kind of going into the factory. And then the machine is controlling everything, packing everything, cutting everything, labeling everything. And then just like things just show up in a pile right on one corner, properly labeled and, eventually packaged, right? That was really, really cool to see.
Yeah, 100%. The Lego analogy, or I was thinking myself kind of the IKEA analogy. Each building is such a unique thing in and of itself, So it was really nice to see the integration between the factory and how responsive they are to the needs of the builder. For us, that was super reassuring, and being a technology that's newer that comes with some of its own challenges, it was really reassuring to see the level of respect that was put towards understanding our building and our needs, and how from the ground up they'd be able to help with the design instead of having to reverse engineer a building where it started as concrete and you want to compare it to mass timber. They would be able to work with us from the ground up and make this building the best use case of the technology.
Yeah, absolutely. Absolutely. And, we saw that there was hardly any waste as well. So it's kind of cool to see the manufacturing process. Materials that you're using on your building project are not negatively impacting the environment.
I think the precision and technology really comes into play because everything is made for order, and because they do a good job of qualifying the materials so that they know which materials will make the best products. That in and of itself makes the defect rate low because you're already pre-qualifying the material, where to use it and where not to use it. When you have that level of intelligence in your manufacturing process, and then you're going the extra mile to make sure whatever wasted is used properly, it's really no wonder why other parts of the world, like in Europe, it's become so well adopted. We do want to have a chat about challenges in adoption as well, which is like a very real impact of this technology.
As a developer, one of the biggest challenges, I mean, there's two major challenges with mass timber or any modern methods of construction, prefab manufacturing in general. One big challenge as a developer is that you're building a conventional building, with conventional construction processes that everybody's used to. Materials and labor on site, is what you end up billing for in your progress draw. So every month, the contractor will bill you for the materials and the labor that they have spent on site, and you include that in your progress draw, and you send that progress draw to your lender releases the financing, you take those funds and you pay the contractor. Generally happens within 30 days, 30 to 60 days. Now the problem with modern methods of construction or prefab is you're not building on site. From a lender's risk standpoint, there's nothing on site to be approved for billing, because all of those panels and all of that material and all of that labor actually lives inside a panelized factory, but it's not on site. So lenders from a risk standpoint are like, well, I'm not going to fund it until this stuff shows up on site. Well, when does that stuff show up on site is when majority of that building is built. So as a developer, you end up fronting the cost of the entire building structure, you know what I mean? Which is very often cost prohibitive, because that is not how the construction industry is set up to release financing. So structurally, there are some significant challenges, which I know that the Canadian government and CMHC is trying to kind of work with, but I haven't really seen anything about it. Everybody talks a big game, but there isn't anything explicitly that's there for developers to kind of specifically address that. Okay. So that's one major challenge. And the second major challenge is that once you get your building permit, that's when the city will allow you to send your drawings to the prefab manufacturer to start prefabricating their panels. Okay. But the problem is, if I've got my building permit and that's when I'm going in to start my manufacturing of panels, might as well hire a carpenter with a decent crew to manufacture those panels on site. Why am I going off site to do that manufacturing? The real way of gaining efficiency is to allow prefab to take place while you're getting your building permit. By the time you get your building permit, your panels are ready to arrive on site and you're simply assembling those panels. Otherwise, now it takes them a long time to do the manufacturing, and then they bring that back to you. And so you lose that months and months and months, which just seems like a big waste of time. There are some structural issues that the industry is facing. As a developer, we're doing our part to create awareness about these kinds of challenges and working with municipalities because these are huge limitations in their adoption.
Yeah, and I think you hit the nail on the head with both of those. Want to end with a little bit of good news. The good news is that in Europe, because the technology is so much farther ahead, it's almost been to the point where the contractor, the builder, they know what they need. And so it has sort of an effect where the manufacturers are working well with the developers, making the product flow quicker, which would reduce these coordination efforts. And on the financing side as well, more adoption is what's going to make the lenders understand these new building practices. And the carbon embodiment is so low in these buildings. There's really a reason to move towards that, with the net zero goals that a lot of these governments are setting. If they want to actually hit net zero, they're going to need to reimagine how they build the building in terms of the draw cycle and the finance, and making sure that builders are able to actually afford to be net zero, bearing a big responsibility. But, I hope it inspires others and leading the way of change.
I just want to kind of quickly point out to one of the things you said, right? Going net zero for a developer, I mean, to kind of have an expectation that the government's got to do something or the lender's got to do something, so that we can hit net zero. Unfortunately, we don't have that luxury of entitlement, right? You know what I mean?
Oh,
And
of course not.
as you know, Daniel, the builders like us who are going net zero and trying to really focus on sustainability are doing it because it's the right thing to do, right? Our business model works. And if we can incorporate sustainability, high levels of sustainability, as in, really, really good building design, while focusing on, profit, planet at the same time, that's the best case scenario. A lot of the builders, people often ask me, right, hey, what's going to be the value of you going net zero or going after sustainability? And tangibly, it's very hard for us to quantify that value. People that are buying or renting our place don't care if it's a net zero building. They're not going to pay more. That's just how market is, and that's how my market dynamics works. You have to make a business case as to why it makes sense to still hit, push the boundaries on the sustainability side of things. And we come up with clever ways of making that happen. So the way we're doing that with mass timber now, extra cautious and careful with our design. So we've got a very, very simple design. And secondly, we just have to make sure that there are no delays in the project. We can beat conventional systems. That's a risk we're willing to take because we're confident in our own abilities. And if we take that risk and we will succeed in it, the net result of that will be the largest locally sourced, locally produced mass timber building in North America, which probably came from a tree not too far away. You know what I mean? Like you're literally living in a treehouse.
Yeah, you said no one will necessarily pay extra for that. And just because it's true now, it doesn't mean that that's always going to way that things go, right?
That's true.
Like it's important that we have identified the benefits, health benefits, relaxation. A lot of people, they walk around a downtown and every building looks the same. You have an individualized product, like it's unique, and people would definitely take pride living there. If we can offer it at a price point similar to conventional, it can get to the point where people would actually prefer this technology. No one can predict the future, but there's really no reason why it can't work, right? Once a project is in place and successful, you never know, and it might completely set a standard, and that's what we hope to accomplish. You could just build any building, but I think it's time to leave it at that.
Yeah.
It's been such a great conversation.
Yeah.
All right. Take care.
Okay, sure.
And
It's been a great conversation. Thank you, Daniel. I appreciate it, brother.